we'll do, write the definition first, then after that we'll continue. Acidimetry. ACID metry, METRY. Acidimetry. What is that? The determination of concentration of bases. The determination of concentration of bases by titration with a standard acid. The determination of concentration of bases by titration with a standard acid is called acidimetry. And the determination of concentration of acids by titration with a standard base is called alkalimetry. Alkalimetry, metry. So the determination of concentration of what you can say acid is called acidimetry with a base. Alright, determination of concentration of bases, by using an acid is called acidimetry, and the determination of concentration of bases, acids by using an acid is called as alkalimetry. Again I repeat, the determination of concentration of bases by titrating with an acid is called acidimetry, and determination of concentration of acids by using the base, means by titrating with the base, is called alkalimetry. We can say that. Now next is the substance which give different colors. Right now, the substance which give different colors with acids and bases are called acid-base titration. The substance which gives different color with acids and bases are called indicators. I said titration. Acid-base indicators. The substance which give different colors with acids and bases are called acid-base indicators. So acid-base indicators are what? Phenolphthalein, methyl orange. They are acid-base indicators. Now next you write, in the selection of indicators for titration, following information are taken into consideration. Point number 1, pH range of indicator, small p capital H. This one, you write pH range of indicator. pH is what? You have studied in lower classes. Minus log base 10 H plus ion concentration. It is a negative logarithm of hydrogen ion concentration. Minus log base 10 H plus ion concentration. When this concentration is given to you, see when anything we write within square bracket, it's said to be as concentration. So what I read it, minus log base 10 H plus ion concentration. This square bracket means concentration. So pH is this. This is known as pH. pH is what? pH is nothing but a universal indicator. You know that. It's an universal indicator which not only indicates the substance is acidic or basic or neutral, but also it gives a value. You know that if the value of pH is 7, it is said to be neutral. If it is less than 7 means 6, 5, 4, 3, 2, 1 in this way. If it goes, then the acidic character increases. Similarly, if it is more than 7, that is 8, 9, 10, 11, 12, 13, 14. If it is increasing up to 14, then what we can say, the basic character increases. You studied all these things. Alright? In this way, there are different colors for acid-base indicators. Which colors? Vibgyor, violet, indigo, blue, green, yellow, orange, right? Green is nothing but is your neutral color for the pH. Clear? Very simple it is. You have studied all these things in the lower classes. So pH is minus log base 10 H plus ion concentration. So what I said, on choosing the indicators, following point you have to remember it. You have to keep in consideration. What is that? The first one is the pH range of indicator. The second point you write it down. The second point, the pH change near the equivalence point in the indicator. pH change near the equivalence point in the indicator. pH change near the equivalence point in the indicator for titration. In the indicator for titration, that means we will choose that particular indicator whose pH range lies within the pH change. Means suppose the pH range is between 4 to 8. So we will select that particular indicator whose pH range is lying between this. Means it can be phenolphthalein, it can be methyl orange, it can be methyl blue. And so many more indicators are there. So whichever indicator's pH change lies within that particular range, that indicators is being chosen for doing titrations whenever we are doing the titration with acids and bases. Understood? Again I repeat, that is, we will be selecting an indicators. So what should be the considerations for selecting an indicators? The pH range we have to consider it, and we have to consider the equivalence point. Alright, equivalence point means at which point the concentration of the acids is equal to that of the bases. That means at which point it attains the end point. Means at which point the titration we need to stop. Alright, we need to stop when the solution becomes neutral, isn't it? You have taken acids and you have taken bases and you are going on titrating. Titrating means what? You are neutralizing the reaction. At a particular point I have said you that which is known as the end point or the equivalence point. What happens? You come to know that what you can say, the reaction is completed. How do you come to know? The color of the pH changes. The color of the indicator changes because pH is an universal indicator. The pH changes. So hence you need to know that particular range. It's not that for any type of acid and base, any type of indicator can be used. Alright, for any type of acid and base, any type of indicator cannot be used. We need to know that which indicator has to be used for which type of acids and bases. Now which type means we are having strong acid, weak base. It can be weak acid, strong base. It can be what you can say, weak acid, weak base. It can be strong acid, strong base. It can also be strong acid base with a strong acid. Means a salt of strong acid base with a strong acid. A salt of weak acid base with a strong acid. In this way. Did you get it? What I said, one by one I will come to it, then you will understand it. So what I said, you need to understand the pH range. So that value I will tell you, you have to write it down. You have to write down that particular value. That which particular indicator should be used for which kind of acid base solution. Alright, what I am doing and you are following, we are doing titration. We are using acid and bases and we are doing the titration. I said acidimetry and alkalimetry. Alright, so for acidimetry and alkalimetry, we should use a particular indicator. So what is the choice of the indicator? Which indicator I must use it? That is what I am saying here. Alright, now first one you write. Strong acid and strong base. Alright, the first category is strong acid and strong base. Strong acid and strong base means, suppose you take NaOH and HCl. That's a strong acid and strong base. So it forms what? NaCl and water. How do you know that NaCl and water is being formed? Same thing I said you need to know the end point. At a particular point you will see when you are doing the titration, it will indicate. The color of the indicator is going to change, by which you will come to know, yes, this reaction has taken place, the titration has taken place, the titration is complete. So what should be the choice of indicator here? Write down. Right. So in the titration of strong acid and strong base, for example HCl with NaOH, in the titration of strong acid and strong base, for example HCl with NaOH, the equivalence point lies in the pH range of 4 to 10. The equivalence point lies in the pH range of 4 to 10. Hence, methyl orange, phenolphthalein or methyl red can be used as indicator. Methyl orange, phenolphthalein or methyl red can be used as indicator. This is the first category. Second category, weak acid, strong base. Weak acid means carbonic acid, formic acid, acetic acid. Strong base means NaOH, KOH, they are the strong bases. Now right, in the titration of acetic acid, let us say acetic acid, weak acid is acetic acid. I am taking an example here. In the titration of acetic acid with NaOH, NaOH is a strong base, already I said you. In the titration of acetic acid with NaOH, the equivalence point lies between 7.5 and 10. Phenolphthalein will be the suitable indicator. Now how do I know? Phenolphthalein will be the suitable indicator. How do I know? Because the what you can say, the pH range of phenolphthalein is 8.3 to 10. Is 8.3 to. Now this all these things you have read it somewhere in class 9 or 10. This particular range, these values you have read it somewhere. Okay. If you haven't studied, once again I am saying you remember it. Now the next category is weak base and strong acid. Weak base and strong acid. Weak base like you can take NH4OH, and strong acid like you can take HCl, you can take it. Right. In the titration of NH4OH and HCl, the pH of the equivalence point lies between 4 and 6.5. Hence, methyl orange and methyl red can be used as suitable indicator. Hence, methyl orange and methyl red can be used as suitable indicator. Why it is so? Because in case of methyl orange, the range is from 3.3 to 4.3, or you can say 3.1 to 4.3. We can say that. And in case of methyl red, it is nothing but 4.3 to 6.3 in this way. What you can say, the pH ranges. Now, next is weak acid, weak base titration. Weak acid, weak base. Weak acid means let us say carbonic acid, and weak base means let us say NH4OH. Now, weak acid and weak base, in titration of weak acid and weak base, you write it down. No suitable indicator is there. No suitable indicator is there. Why? Because the pH range is between 7 to 7.5. So it is neutral. So we don't have any suitable indicator for this. Means we don't have either phenolphthalein or methyl red or methyl orange. We don't have. Because neutral means it will remain, the color will remain the same only. Isn't it? The color is not going to change. Clear? You know that. The color is not going to change. Methyl phenolphthalein or methyl red or methyl orange, any indicator you use it in neutral solution, will the color change? No. Because indicator indicates whether it's acidic or basic. So it is neither acidic nor basic here when you are using a weak base and a weak acid. So we don't have any suitable indicator. So never we go for titration of weak acid and weak base. Never. Alright. Achha. Last one is titration of a salt of weak acid strong base. Titration of a salt of weak acid and strong base with strong acid. Means you are taking a salt of weak acid and strong base with strong acid. Now what I said, a salt of weak acid and strong base. Weak acid and strong base. Salt of, understood? Salt of weak acid and strong base. So which salt can be? Weak acid and strong base it can be. Now base means NaOH, strong base means let us say Na, and weak acid means let us say Na2CO3. Okay, weak acid means carbonic acid, let us say. So from there we got carbonate, and for strong base you got, that is nothing but Na2CO3. You will say how sir you got it? Okay, let me write weak acid H2CO3 plus NaOH. See here, what you will get? We will get a salt or not? Na2CO3 plus water. That's it. So a salt of weak acid and strong base is Na2CO3. Now what I am saying? Now my categories, Na2CO3 will react with, let us say, strong acid HCl. So you will be getting two-step reaction. One is, in first step, one hydrogen ion is, one sodium is being replaced by hydrogen. So you will get NaHCO3 plus, what is that? Nothing but NaCl. Alright, see here. Na2CO3 you got it. Na2CO3 plus HCl. What you will be getting it? Na2CO3 plus HCl. So it will be stepwise reaction, it will be. Alright. So stepwise means the first step, what I am going to get it? The first step. That is, will it be NaCl plus H2CO3? What it will be? It will be NaCl plus H2CO3 or what? Yes, NaCl plus H2O plus CO2. Alright. You will be getting it? Clear? So now what you get it is there is that Na2CO3 and HCl it reacts. So directly will you get this particular product? Will you get this product directly? No, will not get directly. So that is what I am saying. What will happen? First Na2CO3 in the first step. This is a final step. Na2CO3 when reacts with HCl. What you will be getting? You will get NaHCO3 plus nothing but NaCl. See here. NaHCO3 plus NaCl. Now next step, what will happen is that NaHCO3 will react with, what is that? HCl. Alright, this is the final step I said. This is the first step. See, stepwise reaction is going to take place. Na2CO3 reacts with HCl to give NaHCO3 plus NaCl. Now if I take, alright, NaHCO3. You got NaHCO3 from the first step. Now NaHCO3 plus HCl. If I take it, what will happen? See, NaCl plus what I get? H2CO3. But H2CO3 is unstable. It will give you H2O plus CO2. Now you understood how I get it. First step, Na2CO3 reacts with HCl to give this. Now this again reacts with HCl to give you this. Alright, now listen here. In the first step, in this step, phenolphthalein is a suitable indicator. In the second step, methyl orange is a suitable indicator. So this sort of a salt of weak acid and strong base with strong acid, this sort of titration is a complex titration. It is an acid-based titration, but it's a complex titration. It has to be done in two steps. First step, we will use phenolphthalein as an indicator, and second step we will use methyl orange as an indicator. Because the pH range of the first step lies within the range of phenolphthalein, and the second step the pH range lies within the, what you can say, range of, that is methyl orange, we can say that. Clear? Because methyl orange I said you already 3.1 to 4.3 in this way, and for phenolphthalein I told you already that it lies between nothing but, we can say that 8.3 to nothing but it is 8.10 or something like that. The pH range lies. Got it? That is, for that particular reason we can use this particular indicator for titration. In the first step, remember phenolphthalein. In the second step, you remember methyl orange, because the range I have said you, in that particular range it lies, so hence we are using it. So got it now? Which indicator is suitable for which kind of titration? For salt of strong acid, strong base, one indicator. Salt of strong acid, weak base, another indicator. Salt of weak acid, strong base, another indicator. For weak acid, weak base, no indicator is suitable. Salt of strong acid, what you can say, and weak acid and strong base with strong acid. We have got two types of indicators. In the first step we use phenolphthalein, and in the second step we use methyl orange. Alright children, clear? Now the numericals upon it, how it is going to come and all those things. Now I told you the theory, the numericals upon it, I'll do it and I'll send it to you. Thank you very much.